In this video, I'm going to go over problems 26 to 29 on adding and subtracting rational expressions. So 26 is supposed to just be a real quick, short problem. So it's 8 over 11 plus negative 3 over 11. So it just reminds you, hey, to add fractions, if they have a common denominator, which they have to have in order to do it, you keep the denominator and add the numerators. 8 plus negative 3 is 5. X over 6 plus 2 over 6, common denominator, keep it, and then x plus 2, that just becomes x plus 2. You don't want to simplify this 2 over 6 to 1/3 because then you don't have a common denominator. But then this last one here is 1/3 plus 2/5. So remember, when going way back, when fractions don't have a common denominator, you have to give them a common denominator. So you give them a common denominator by multiplying each fraction by essentially by a 1. So with 3 and 5, we know the common denominator would be 15. So here we multiply by 5 over 5. Again, we're able to do this because it's really just a 1. And you're multiplying the second fraction by 1, but what's in your 1 here is 3 over 3. No, you don't need to write those big ones moving forward. So we get 5 over 15 plus 6 over 15. Now that we have a common denominator, we just add our numerators. That's just a quick little reminder on adding and subtracting fractions with common denominator and without a common denominator. On problem 27, I believe each of these has a common denominator. So for part A, we have 2x over 2x squared plus x minus 21 plus 7 over 2x squared plus x minus 21. So since we have a common denominator, we keep that denominator, 2x squared plus x minus 21, and we add the numerator since it's addition. 2x plus 7 is simply that, 2x plus 7. The second bullet point on the directions says simplify your final expressions if possible. So in order for this to be simplified, we'd have to have something the same on the top and the bottom, numerator and denominator. So we have to factor this denominator. So again, your box and your diamond, or just your box, this is 2x plus 7 over, so 2x squared plus x minus 21, that factors into x minus 3 times 2x plus 7. A lot of these problems, they're going to have the factor the same in the numerator and denominator, so you will be able to cancel them out. So those cancel out. Remember, you're left with a 1 on top. When these cancel out, it's really making a big 1 over x minus 3. Part B here. 5x over x squared minus 2x minus 3 minus, this one's subtraction, 15 over x squared minus 2x minus 3. So we have a common denominator, makes it much easier. X squared minus 2x minus 3. My numerator is 5x minus 15. And now we have to factor. The numerator 5x minus 15, that has a common factor of 5. So if I factor out that 5, I have x minus 3 in the parentheses, basically the distributive property backwards. Again, box and diamond, I kind of did it ahead of time. We know what this factors into. It's x minus 3 times x plus 1. So we have an x minus 3 and an x minus 3. And this will give us 5 over x plus 1. Part C, 3x plus 9 over 8x squared minus 50 minus x plus 4 over 8x squared minus 50. So, common denominator is 8x squared minus 50. In my numerator, I have 3x plus 9 minus x plus 4. Some of you aren't going to write this extra step. That's fine. I just want to show you that you're subtracting this whole thing. So this becomes 3x plus 9 minus x minus 4 in my numerator. And my denominator is still 8x squared minus 50. So my numerator simplifies to 2x plus 5. My denominator is still 8x squared minus 50. Some of you are going to go straight from this first step to here. You're going to recognize, hey, it's subtraction, so I have to subtract both of these terms, and that's fine. I just want to kind of break it down for you. You're really subtracting this whole numerator, which means you distribute the negative to the x plus 4, and then you combine your like terms. Alright, so I'm just going to, in my denominator, I can see I have a common factor here of 2, a GCF. So 2x plus 5 in my numerator over 2 times 4x squared minus 25. So again, I factored out a 2 in the bottom, distributive property backwards to get 4x squared minus 25. From here, you can make your box and diamond, or hopefully you recognize that this is a difference of squares. So I have 2x plus 5 in my numerator. My denominator, that 2 stays there. The square root of 4x squared is 2x. The square root of 25 is 5. So it's a 2x plus 5 and a 2x minus 5. Well, 2x plus 5 and 2x plus 5 get to simplify into a big 1. And I'm left with 1 over 2 times 2x minus 5. And finally, part D here. We have x squared plus 5x minus 2 over 3x squared plus 2x minus 8 plus, when it's addition, that's nice, you don't have to worry about distributing any negative. My second numerator is 2x squared minus 3x minus 6, and my second denominator is the same as the first one. So common denominator, I'm just going to keep it right away. 3x squared plus 2x minus 8. I can worry about factoring later. Here, adding, so x squared plus 2x squared, I get 3x squared. 5x plus negative 3x is 2x. Negative 2 plus negative 6 is negative 8. What do you notice here? So without factoring, this just simplifies to 1. The numerator and denominator are the exact same. Okay, so those are with a common denominator, and then remember you just have to kind of factor afterwards. But on 1128, these problems don't have a common denominator. So it goes back to kind of this first problem up here, the last part of it, and we have to make a common denominator. So on 28a, we have x over 3x plus 1 plus 2x squared minus 2 over x minus 5 times 3x plus 1. So take a minute, look at both of these fractions. What do they have in common? So we're adding fractions, so we need a common denominator. To get a common denominator here, you can see that this has a denominator already of 3x plus 1. It's not written with the parentheses around it, but you can write them around it. So we're missing in this first denominator an x minus 5. So we're going to multiply this first fraction by x minus 5 over x minus 5. And that's really just a 1. So by multiplying that, I have x minus 5 times x over x minus 5 times 3x plus 1. Just writing it out as one fraction now instead of the multiplication, plus 2x squared minus 2 over x minus 5 times 3x plus 1. Now I have a common denominator. I could have distributed from this first part, which would have made it a little bit easier. So this numerator here, x minus 5 times x, is equivalent to x squared minus 5x. So I'm going to just add both of these. My denominator is x minus 5 and 3x plus 1. But now I have x squared plus 2x squared, so I have 3x squared minus 5x. There's no x's here, so minus 5x and minus 2. From here, I got to factor the numerator. My denominator is already factored. We have to factor the numerator to see if anything will simplify. So my denominator stays x minus 5. My numerator is 3x plus 1. And remember, I don't really want to necessarily go over the factoring, but you could kind of draw an arrow. You could do all of your factoring off to the side for the problem. So 3x squared, negative 2, that's negative 6x squared and negative 5x, which would give you negative 6x and x. So kind of going a little bit quickly here. But I see that it factors into 3x plus 1 and x minus 2. Which my 3x plus 1's crossed out, and I'm left with x minus 2 times x minus 5. Whew, that was a lot for one. And then part B, the last part of these uncommon denominators here, is 9 minus 3x over x plus 3 times x minus 3 plus 2x over x plus 3. So we need a common denominator, add our fractions. So they both have an x plus 3 in the denominator, but this one also has an x minus 3. So we need an x minus 3 in this denominator. And an only way to get an x minus 3 there is to also multiply by an x minus 3 in the numerator, because I have to multiply by 1. So 9 minus 3x over x plus 3 times x minus 3 plus 2x squared minus 6x over x plus 3 times x minus 3. So I went ahead and distributed that numerator, the 2x and the x minus 3. So now I have x plus 3 and x minus 3 in my denominator still. This is addition, so I don't have to worry about any distributing negatives or anything. 2x squared, negative 3x and negative 6x, so we get minus 9x, and then I had a 9 in front, which makes that plus 9. So same idea, I want to factor this numerator now. My denominator is factored, nothing can cross out until I factor my numerator. This numerator factors into 2x minus 3 times x plus 3, and my denominator stays the same. X plus 3 times x minus 3. I can see that my x plus 3's are going to cross out. And I have 2x minus 3 over x minus 3. Nothing here can simplify. You have to leave it exactly like that. And that's your final answer there. On 29, I'm going to just do part of it. Explain why x cannot be 4. So on part A, it says x plus 2 over x minus 4. So x doesn't equal 4 because if x equals 4, we would have 4 plus 2 over 4 minus 4, 6 divided by 0, and you can't divide by 0. Oops, that says can't divide by 0. What part B wants us to do is state the excluded values for problem 28. So looking back here on part A, these were my factors in my denominator. So for part A here, x doesn't equal 5, and it also doesn't equal negative 1/3. Remember, to find the excluded values, you just set each factor of the denominator equal to 0. And then for part B, I had x plus 3 and x minus 3. X doesn't equal 3 or negative 3. This 3 goes in the second one. I wrote them backwards. Doesn't matter. There is a part C. It says create an expression that has excluded values of negative 6 and 1/3. That's up to you. If you want to kind of try to challenge yourself, see if you can come up with one of those. There are infinitely many answers there. So, but that is it on adding and subtracting rational expressions.